Hey, kiddos. New day. 2 new tests today. Because one of them's so fast, it's just not worth doing by itself. Here it is. If you have the sum and you have a 1 and it's over, n raised to some p for power. We'll start at 1 and go forever. It's very quick. If p is bigger than 1, converge. If p is less than or equal to 1, diverge. I can prove it to you, but then you wouldn't watch my video. So maybe I'll prove it to you one day when we're all back together in class and you have no choice but to pay attention. Wahaha. So they'll try and get you on these. They'll try and make you think that these are more difficult than they are. And they'll give you something like this. Oops, sorry. How about like 4/3? It's not an absolute value on those p's. So don't get it confused with your geometric where you take absolute value. And don't get it mixed with your geometric, because geometric, you need absolute value of r to be less than 1. So this one's backwards. What you need to do is you need to rearrange it. It's got to be 1 over. But this would be 1 over n to the 4/3. And then I just simply say p is 4/3. That's bigger than 1, therefore converges. And I'm done. And I move on. Great. You have a delta waiting for you to practice p-series. That's lovely. But p-series is actually used for something a little bit more advanced called basic. Basic comparison test. It's so advanced, they call it basic. Basic comparison test. Here's the premise behind basic comparison test. Basic comparison test says, if you have a series that looks like a series you know, we can compare them and say that they do the same thing. That's an N. So here's what I mean. This is a terrifying series. You're scared. I know you are, but it's actually not that terrifying, because I say that out at infinity, this thing looks really close to 1 over n. Oh, this is supposed to be cubed. I'm sorry. 1 over n cubed. Why do I say that? Well, because n cubed is n cubed. That's not a big deal. I'm not scared of sine. You're not scared of sine either. Sine is stuck between -1 and 1. So the biggest it will ever be is 1. So let's compare it to 1 over n cubed and not worry about the sign. So I'm going to use p-series here. I'm going to say p equals 3 greater than 1, therefore converges. And now I'm going to do a basic comparison test. So this work, yes, I used it to test. I sure did. But that was to prove the series that I think it looks like. Here's what basic comparison test says I'm supposed to do for a convergent series. If I think that this sine of n over n cubed looks like 1 over n cubed, and I know that this series converges, I know it does because it's p-series and it's so fast, then the series that I was given to prove, this sine of n over n cubed, if I can show that it is less than the one I know it looks like, it's also going to converge. Because if we are approaching a value over here, I don't know what value, but we're approaching a value, and the series I say it looks like out at infinity is underneath, then it must also approach a value, because it can't shoot off to infinity if it's underneath. So that's the inequality I set up. It's an inequality setup. Now, I've got to solve my inequality and get it to a place where it makes sense, but this one's really fast. You want to crisscross applesauce? We can. We don't need to, but we can. You want to divide by n cubed? We can. Ta-da. And I end up with a statement that is always true. Sine is always less than 1. And I know that because that's how I picked the thing to compare to in the first place. So if this is always true, we say, therefore, the one we were given also converges. So to recap, we were given something scary. We picked its pieces that were the most important. We boiled it down to its major players and proved that one instead. Then we set up this inequality to say that if ours is underneath because it converges, ours also converges. Let's see what this looks like from a divergent point of view. We'll do a different series. So what if I had something like this? Okay, I don't know what's going on there. I don't know what that does. But if I pull major players, so out in infinity, the numerator is n. The denominator, guys, I don't care about -2. If I'm at infinity, -2 is not affecting much. So we are instead going to compare this thing to 1 over n because I'm reducing that down. Oh, well, this is harmonic. I learned about harmonic last week. It diverges. I don't have to prove it. I don't have to do any test. Everybody knows harmonic diverges. So if we're going to compare to a divergent series and we're going to set up our inequality, that's -2, and I'm comparing to 1 over n, then if I know that the thing I'm comparing to diverges and I want to set up an inequality, this time I want my inequality symbol to go this direction because the thing I'm trying to prove, if that's above a series that shoots off to infinity, then it also shoots off to infinity. I can't compare less than because it might or it might not. We won't know. All right, crissy crossy apple saucy. And I get n squared greater than n squared minus 2. I can subtract an n squared from both sides, and I get 0 is greater than -2. Always true. Therefore, the one we were given also diverges. I always use this word also in these statements because under no situation, if I had compared this to a converge, my conclusion could not be diverge. If you're going to compare it to a diverge, you have to prove divergence. If you're going to compare it to a converge, you have to prove convergence. So if you get in a situation where you get something that's not always true, you did something wrong, or you picked a wrong test, or you probably just picked a wrong test. All right, let's go to our series list. We have 2 to add here. So let's do P series first. P series, so these are all look like 1 over n to the p, power of p. We're going to converge when p is greater than 1. We're going to diverge when p is less than or equal to 1. That quick. Basic comparison is not as quick to write. So for basic comparison test, if we are given and we compare to a different one, and we can prove that that one converges either by p-series or a quick geometric or something. It doesn't have to be p-series. Then we have to show that our series that we were given is less than or equal to the one that we know. And then same thing over here. We're given a sub n, and we have to and we're going to compare it to b sub n, which we know diverges. Then we have to prove that the one we're given is bigger than or equal to b sub n. All right, kids. Have fun. Let me know if you need anything.